Yeah, hi. I'm Eric, otherwise known as Antipax on pretty much everything. I'm the director of engineering at FanDuel. I'm building a game called NBA in Play, which is kind of like a really, really fast fantasy sports game where you pick one NBA player per quarter of a basketball game. You get points based on how well they do, and you get a little turbo button that gives you extra points for a short period after you hit it. So that's all built in Elixir using Phoenix and all that kind of good stuff. So I got into OTP and Erlang via Elixir. I've been doing Elixir and OTP full time for around 3 years now. I'm a contributor to Elixir, Phoenix, Ecto, and Postgres. And I'm also the maintainer of the GenState machine package, which is a nice Elixir wrapper for the GenState library in Erlang, which I'm going to talk about a little bit today. And I'm also not a fan of excess dependencies. So, what does that mean? Like, what's an excess dependency? I think to understand that, we kind of have to understand what the advantages and disadvantages of adding a dependency to your application are, right? So why are dependencies cool? Obviously, reusing code is better than rewriting it because it's less effort. Bug fixes for code and your dependencies are shared amongst all of other applications that are dependent on that dependency. So you kind of get free maintenance, maybe. And if you learn a dependency once, you can reuse and share that knowledge, right? So like if you use Phoenix to build your web application, then everybody who's ever used Phoenix kind of understands your application a little bit better than they would if you had built something like Phoenix yourself. But why are dependencies not cool, right? You're trusting the maintainers of the dependency to maintain it, right? So if they abandon the project or they're not doing a great job, you might end up in a less than optimal situation, right? And you're also introducing code that you might not fully understand to your code base. You could run into unexpected behavior in production. You could run into bugs. You can run into performance issues because you haven't really looked at the code that you're including in your application. You just added it as a dependency, looked at the docs, calling some APIs, and maybe you didn't really totally understand what it was exactly doing. Also, another big problem is that your dependencies can have dependencies, so on and so forth. And so I think we've all probably been in a situation where you've had either a ridiculous amount of dependencies in like a Node app or something like that, or dependency conflicts in Elixir or Erlang. I think Renan was talking about that in this room yesterday, where I think there was two like UUID libraries or something that conflicted because they were using the same name. So those types of issues happen. And I mean, like, the conclusion you can take from this is that dependencies are awesome, but you should avoid them when you don't need them, right? Because if you don't need them and you can get away without them, then you don't need to take the disadvantages of them on. So how do we avoid unnecessary dependencies, right? There's like kind of two ways, right? We can write simple things ourselves and avoid the left pad happening to us again. Or we can use functionality from software that we're already dependent on when it's possible, right? And so in this talk, I'm obviously pretty much focusing on this latter one here, right? And so the question is like in Elixir, how much functionality is actually available to us, right? And I just kind of want to take a little aside here and say, with Python, right, probably a lot of people have heard this before, this sort of phrase, batteries included, right? And so this is a quote from Wikipedia, right? Python has a large standard library, commonly cited as one of Python's greatest strengths, providing tools suited to many tasks. All right, this is deliberate and has been described as a batteries-included Python philosophy, right? And that's a little bit different about how we do it in Elixir, right? Like with Elixir, it's more like you ain't gonna need it. So I wrote this to kind of put some contrast here, but Elixir has a very small standard library, which is also commonly cited as one of Elixir's greatest strengths, which provides a small, easily learned tool set suited to many tasks. And I think Jose was actually hitting on a lot of this stuff in his keynote. And so this is obviously a very deliberate thing and is an important part of the maintainability of Elixir and code written in Elixir. So I hadn't spoken to Jose before I wrote this talk, but there's a lot of parallels here, actually, I think. So the nice thing about Elixir is that even though we have this really small standard library that's in Elixir, we actually also have access to all of ErlangOTP. And there's a lot of stuff in ErlangOTP. So let's take a look at a couple of the things that I've run into in my work that I think are cool, and talk about what you might use them for and what they kind of support. So figure it makes sense to start with disk log because it's in the title of the talk. It's very accurately named. It allows you to efficiently log any term to a file, right? So if you have any value in your Elixir code, you can just say, take this and just write it to a file. You don't have to worry about how it's being serialized. You don't have to worry about how to deserialize it. But perhaps more interestingly, it actually allows you to read terms back from the file in efficient chunks. So you minimize your disk access and your memory utilization. And so it's actually extremely useful for stuff like audit trails, recordings, write-ahead logs, that type of thing. So in NBA in Play at FanDuel, we actually use disk log to record all of the statistical events that come into the system from our stats providers about what's happening in basketball games and stuff like that. And then we take those disk log files, and we'll actually play them back into the system at a later date to simulate those games and enable us to test when there isn't actually a basketball game happening. And the reason we originally used, we would just take the entire list of all of the events in the game, and we would just dump it to a file with term to binary, which if you're not familiar with that function, it's a function that takes any value and it turns it into some binary, and you can just dump that to a file. The problem with that was that we would load all of the data into memory at once when we would load that recording. And that's a lot of data, and by switching to this, we were able to really reduce our RAM utilization a lot, so it's pretty cool. Another really nice feature that we don't use too much is that it actually supports recovery from corrupted logs. So if your application dies for whatever reason in the middle of writing some message, the disk log module will actually be able to detect that that entry was not completed properly and will not include it and can repair the file, allowing you to continue to use the data that was written. You also have the ability to do asynchronous or synchronous logging and logging from multiple processes, including having a process block other processes from logging while it's logging. So this is a really useful tool. One really cool thing you can do with this that I haven't done myself personally yet, I think, is that you could probably combine ETS and disk log, and you'd end up with a ETS with persistence that you have a little bit more control over. So it's similar to DETS, which is an ETS that just writes everything you do to a file as soon as you do it. So that doesn't work for every use case, but when you combine ETS and disk log yourself, you can, depending on your requirements around the persistence of that data and when it actually needs to be persisted to disk, you might be able to get more performance and still have that persistence. So just a really quick example of how you can use it from Elixir. So you specify a log name and a log path, you open the log, and then from there on you just kind of log using the log name and whatever term you want to log. You sync it to disk and you close it. And reading is just about as simple. You open the log again, use this chunk function, passing start as the second argument, which will give you the beginning of the file. And then as you can see in the result of that, we have the term, which we logged in the previous slide, but we also have a continuation, which in this case is the atom EOF, indicating that we've reached the end of the file. If we had more terms logged in this file, we would actually have sort of a special continuation there, which we could use as that second argument instead of start, and we can continue progressing all the way through the file like this. One cool library I think that would be awesome, or one cool hex package that isn't out there if anybody's looking for something to do, would be to take this API and wrap it in an Elixir stream. Should be pretty easy and pretty useful. Okay, it's a little boring, right? But when you need it, you will be really glad it's there. I promise you'll run into some situation where you're like, I need to store a lot of stuff on disk, and I need to load it back into memory, and I can't load it all at once. It's going to be very useful for you. So how about something maybe a little bit more exciting? Amnesia. Whoops, wrong Amnesia. So yeah, Amnesia. Some of you probably have heard about this. Somewhat disturbingly named for a database. Amnesia is a distributed DBMS that's actually built into OTP. So you can store your data directly as terms, and you can query them using query list comprehensions and match specs. So this is a lot like ETS, except your tables can easily be replicated to multiple nodes, persisted to disk, and have multiple indexes. So in ETS, normally you can only look up a row by its key, but in Amnesia you can actually set up indexes on any row, I guess, or column. So another cool thing that Amnesia supports is a thing called table events. So you can actually receive messages through a gen event manager, which tell you about when a new row has been written to your tables or when a row has been deleted to your tables, from your tables, excuse me. So it might be a useful thing if you, are interested in doing something in response to some record being inserted successfully in your application. So in terms of, cap theory, Amnesia is a CP database, so you get really strong consistency guarantees, but your tables can become entirely unwritable if and when a net split occurs. And so that's because Amnesia was, as I understand it, originally built to support telecommunications use cases, which is what Erlang was built for, right? And Amnesia used to run, and Erlang used to run within these switches that would have multiple computers in them, essentially. And the network between them, you would assume it would not go down because it was literally all in the same box, right? So Amnesia works perfectly in the case where you aren't too worried about net splits. So, should you use it? I was on Elixir Fountain like a couple weeks ago, and Johnny asked me something about Amnesia, and I was just like, you should never use it. I want to take that back. Because I do know some people use it and have a lot of success with it. But I just want people to be aware that there are caveats and limitations. And you're also saying, I'm going to pay the cost of learning and maintaining an entirely new DBMS, right? Like, any database system is really complicated, has a lot of stuff that you have to learn about it to use it, to maintain it, take care of it. And so it's a fantastic tool for what it's good at, but it's absolutely not a general purpose replacement for something like Postgres. So if you're maybe building a web application and you're just interested in maybe not having any extra dependencies, that your application is only going to run on a single node, or maybe that your application is going to run in a data center where that your nodes are always going to be able to talk to each other with reasonable confidence, this might be a good solution for you. So just a quick show of hands. How many members of the audience work at a company with Java in production? Yeah, I thought so. It's pretty much everybody, right? I mean, even I I think at FanDuel, most of our code is still Java. And one really cool thing in ErlangOTP, which has saved my bacon a couple times, is Jinterface. And so it's a very Erlang-y way for Java code to interoperate with OTP nodes. So what does that mean? It actually provides all of the fun Erlang inter-process communication stuff, like nodes, processes, mailboxes, and process monitoring, but for Java. So it's literally like a jar that you get. It's a library giving you a Java API that allows your Java code to pretend to be an OTP node or process. So because of that, it's not as easy as your standard kind of foreign function interface where you just say, I want to call function on this class with these arguments, and you call that code directly and you get your response back, right? Usually with Jinterface, you have to wrap your existing code with some new code that sort of behaves like a server and takes in requests, handles messages, handles state, talks to the existing Java code, and returns an answer to your system. And one weird Jinterface trick they don't want you to know is that you can make all of your Java code fault tolerant by wrapping it in Jinterface processes and supervising them. Yeah. Not really, don't do that. I mean, I think that I've had this idea. I've never really tried it. I've never really put that much thought into how well that would work. I would imagine you wouldn't want to start a whole bunch of JVM processes, one per process. That wouldn't be good. But if you had a bunch of processes running in one JVM that are using your existing code, and you're supervising that from Erlang, it might be kind of cool. I don't know. Something to check out if you're looking at experimenting with stuff. So Java interface, cool, right? Graphical user interface, cooler. So WX is an interface that's built into Erlang to a thing called WX widgets, which is a cross-platform GUI library. And so this is actually used within Erlang itself to implement the observer, which Jose mentioned in his keynote. And I think this is probably the thing that everybody goes like, hey, you want to see how cool Erlang is? Yeah, type observer start in IEX. Like, this is awesome. So if you haven't seen it, check out the observer, but WX is used to implement this. So it's got a bit of a weird and verbose interface because it actually directly maps like a object-oriented C API into Erlang. So if you're going to use this, be prepared to have some really weird code that kind of looks like it's object-oriented, but it's actually functional. However, it does have the ability to put an OpenGL canvas within a window, and it has bindings to GL and GLU. So if you're looking to just do your own drawing in Erlang, and you're okay with WX's being built into your VM, then this might be a cool way to do drawing. So this is just an example of the kind of thing that's possible with WX. This is the observer. So you can really draw pretty much anything. You can use native UI controls for that operating system that you're using, all that kind of good stuff. So should you use it? Sure. But again, it's like pretty hard to use and maintain, and it doesn't really fit into the Elixir kind of Erlang way of doing things. It's got all this like weird mutable state and everything that you have to handle in your functional code, and you probably want to wall it off behind some kind of adapter so that you can have your nice functional code on one end, and then the dirty non-functional kind of code in a different part of your application. So graphical user interfaces are cooler than Java interfaces, right? But an SSH interface, that's probably the coolest, right? Terminal, command line, it's way cooler. So SSH is another library that's built into Erlang. And it provides actually both an SSH client and server. So this is built into Erlang. Like, you don't have to have OpenSSH installed. You don't have to have any of that. And the client and the server are totally customizable via callbacks. Like think GenServer. So when you start up a server, you can literally specify a module that gets a callback every time some kind of line comes in from the SSH client and can send messages out to the client. It has SFTP support built in, which is sort of cool. And here's a couple of fun ideas for the SSH module. You could provide an IEX session or some kind of specific shell for your application via SSH without any extra dependencies. You could make a MUD, old school multi-user dungeon game, using SSH implemented in Erlang. And just as a kind of fun thing, maybe you could try to generate the character from like a hash of the user's public ID or something like that. I thought that would be kind of cool. And you could also, technically, I'm not sure about the exact performance implications of this, but you could use SSH as just a general two-way transport for your application. You know that it works, you know it's supported in multiple languages, and you know that it's secure. So it might be a really good way to connect servers together and that kind of thing. So, but now that your communications are safe, right, what about your types? Dialyzer. Probably a lot of you are familiar with this, but if you're not, it's a built-in success typing tool for Beam code. So it helps you avoid type errors in your code. Although, like I think Jose has mentioned this before, that in a functional language, your value errors are much more common, right? Because we have so few types in Elixir, sort of. We have, maps, we have numbers, we have atoms, and not much more than that. Usually the errors that you're going to see in your Erlang programs are because you've done something wrong. You've added when you should have subtracted. You've done something like that. But it is really nice to be able to check and try to find these errors that can be found. And so when I say success typing, this means that not all type errors in your code will be detected by Dialyzer. But the ones that are actually guaranteed to cause a crash. So you'll never get a false positive from Dialyzer. Although some of the messages won't be useful, even though they're correct. So I really suggest that if you want to use Dialyzer, check out a project called DiElixir. It's on Hex. It adds a task to Mix, and you just run that, and you'll get type checking in your application. Pretty cool. But what if you're writing your own language, and you want to take advantage of that typing? Well, you could use two tools called Yak and Lex. which are built into Erlang, and somewhat nauseatingly named like its spiritual sibling Yak. Yak is a parser generator which outputs an Erlang module from a grammar. So what you can do is you can specify, these are my rules for how my language behaves, and you can say whenever I see this pattern in my in a string, I want to emit this code, do this thing, and yeah, so that's one of the basic building blocks of a compiler. Lex is a lexical analyzer generator, which is similar to Lex, which is another existing tool, except, again, it generates Erlang instead of C like the original tools do. And so Yak is actually used in the Elixir compiler. It's kind of a complicated tool. I'm kind of just trying to run through as many of these things as I can in as short of a period of time so I can share as much with you guys as I can. So I can't go too deep, but I suggest that you check out, if you're interested in this file in the Elixir project, which will kind of give you a really real-world example of how to use this tool. And so if you ever get to the point in an application where parsing binaries with pattern matching or regexes or whatever isn't doing the trick anymore, then maybe go and check these tools out, because they're kind of what's, this is what is used to build parsers and lexical analyzers, all that kind of stuff. So what is a parser but a state machine? I want to talk a little bit about GenState now. This is a pretty recent addition to Erlang, but somewhat generically named. GenState provides a state machine behavior for processes. So state machine, just in case you're not familiar with that, is kind of a abstraction that's used in computer science to describe the different states and transitions between them of some sort of process. And so a lot of, for instance, a good example of a state machine would be when you go to connect to a server, you have to usually do kind of handshake according to whatever kind of protocol you're using to talk to the server. And depending on what step you're in that process, that's what state you're in. And as the server is responding to you, you're transitioning to other states. Like, I just said hello to the server. If it says hello to me back, then I'm going to acknowledge that hello. But if it doesn't say hello to me within 5 seconds, I'm going to restart by saying hello again. That kind of thing is a state machine. And they kind of pop up a lot in code everywhere. Parsers, network code, like I was just talking about. Games are state machines usually. When you have a title screen that goes into the actual game that might go to a high score screen or something like that, that can be represented as a state machine. And the biggest difference from GenServer is it has the ability to emulate selective receive. So when you go and you say, in Elixir or Erlang, you say receive, and you specify the type of message that you're interested in receiving, if there's any other messages in your process's mailbox that don't match that, they'll just sit there in the mailbox. And you actually can't do that in a GenServer, because the GenServer expects to have control over what messages are received. So if you try to do this in a GenServer, you may end up messing up internal processes in the GenServer. And so what this allows you to do is it allows you to easily defer the processing of incoming events during states that you're interested in deferring them in. So like, let's say I have a request out to a server, and I'm waiting for a response from it, right? I may say, even though I may get some requests in the interim to make more requests to that server, I may say I want to postpone those until this request is complete before I continue on. And that's a little bit hard to do in a GenServer without a lot of extra code, and GenState makes it easy. Also has some nice things. So you can gather all the code for a state together in the same place, instead of having to have it spread across handle call, handle cast, and handle info, which is just nice to have. And there's also a library called GenState Machine, which if you don't want to use kind of the base Erlang implementation where you kind of have to specify all of your callbacks, including code change and terminate, which we're usually not interested in, you can check out this package on Hex called GenState Machine, which gives you an Elixir-style GenState machine. It was written last year around the time that GenState was still an experimental addition to Erlang. And it actually provides automatic backwards compatibility because, again, it was an experimental API, so it actually changed quite a bit. And this wrapper will actually make sure that regardless of what version, so let's say if you're distributing your library on Hex, if a user has Erlang 19 or 20, your code will just work just fine. You don't have to worry about it. So if you're interested in learning more about GenState, you can go check out the slides for my talk on this, which is called Stately Machines, which is at my site, ericent.in. So now the lightning round, the stuff that I wanted to cover but couldn't because I'd already covered a lot of stuff. So there's a module called digraph in Erlang. It's pretty cool. Lets you do labeled directed graphs. So this is actually used internally in Mix to resolve your dependency graph and figure out what dependencies need to be installed. There's a couple libraries, zip, ErlTar, and zlib. So a lot of times when you want to decompress or compress something, you might just shell out to the system. You might just say, okay, I'm just going to do bzip2 whatever, blah, and run it as a separate process. You don't have to do that. You could use the built-in stuff. So there's two modules, global and PG2, which PG2 I spoke about last year at ElixirConf. But these provide cluster global process registration, locking, and groups. So they're a little bit, they're not going to scale very well because they both involve global locking, which involves your node. When you say, I want to register this process for this name, you actually need to go out to every other node in the system and say, I want to lock, I want to lock, I want to lock. And they all have to say back to you, okay, you're locked, before you can proceed and do whatever it is that you were doing. So it'll work pretty well in a small cluster, but as your size of your cluster grows, this cost that you're paying to lock is going to increase and increase. And if you have thousands of processes that are registered or in groups, it's going to become a problem. So great for if you have a small number, constant number of processes in a relatively small cluster, but not so great if you have a large cluster or a lot of processes. So there's another kind of module slash program, binary, whatever you want to call it, that's included with Erlang, which is called heart. And you can specify -heart on the command line as an Erl option to use it. And what this will actually do is a second process will be started, which will communicate with your beam process. And if either one disappears, does not respond to a heartbeat from the other within a certain period of time, then it will restart the other. So if your heart process disappears, Erlang will start heart. And if your Erlang process disappears, heart will start your Erlang process. So this sort of thing might be handled by systemd service or upstart service or whatever, but you can actually do it without that. So another cool library, RPC. So if you just need to call some module and function with some args on another node and you don't want to get into creating like a gen server specifically to handle the request, you might want to check out RPC. So what it will actually do is it's a server that's running by default on every Erlang node. And when a message comes in from the RPC library from another node saying run this module function with these args, it will actually create a new process to perform that call to that MFA and return that value over the network to the calling process. So it's pretty cool. One thing to be aware of with this is that I think as Simon spoke about yesterday in this room, creating processes does have a cost associated with it, right? So if you're using RPC very heavily, even though we're creating a new process to handle each request, that single gen server which starts those processes may become overloaded. So don't rely on this too heavily, but if you just need to, let's say when a node starts up, ask another node for some data one time or something like that, this might be a nice tool to do that. Beamlib is also pretty cool. So Jose was talking a lot in his keynote about all the different various chunks that are in Beam files. Beamlib allows you to actually take an existing Beam file and disassemble it into its constituent chunks. Then you can actually look at them and see what data is in the file. So you can actually, this is one way to take a Beam file, disassemble it, and then actually look at the Erlang AST that was generated, or the core AST that was generated for your Elixir code. So if you're ever interested in kind of seeing how is Elixir code, or a particular kind of Elixir code, translated to Erlang, Beamlib is the way that you do that. And then proclib, I just wanted to mention this too. Proclib is used under GenServer and GenState, I believe, to actually implement those libraries. And so this module provides functions which will allow you to be a nicely behaved process in an Erlang system. So one thing that GenServer does for you, which is kind of nice, is when you ask it to start a GenServer, the start link function actually won't return until the init function of your new process returns. So if you want to build your own processes that have that kind of behavior, proclib contains the functions that you need to do that. It's a function called init-ac. So pretty cool to check out. Whoa, too many. XML, last one I want to talk about. Sorry about that, but it's a built-in XML parser. What you can't see there is I'm saying, can we please get Jiffy, which is the JSON NIF, into OTP itself? We have an XML parser. Why can't we have a JSON parser? Please, guys, if you're out there. So the list goes on, but I can't cover them all. So I just kind of want to go back to the original sort of framing for this very wide and broad view on Erlang. But we can avoid unnecessary dependencies by using functionality from the software we're already dependent on. So always take the time whenever you're working on something before you add a dependency. Go and look, what do I already have? What can I already use? So the big important part here is when possible, though, too, right? So some of these libraries that I've shown you today, I've said they have major caveats. They have major implications for using them. So make sure you're aware of what you're doing and use the dependency if the thing that is built in is not good enough for you. So, yep. So thanks. Yep. So I think we have a little time for questions. I'm happy to answer anything about the presentation or anything that anybody wants to ask.
Questions?
Is there anything you found in OTP that you've thought about using but then decided it wasn't going to fit your use case?
Yeah, sure. So there's one module in the standard library called pool. So what that does is it's kind of this sort of obscure functionality that allows you to have one node that starts a number of nodes that will receive code from that node and then follow the instructions of that original node. And pool is a library that allows you to do that, but what it will actually do is it has a single interface function, which is it allows you to spawn a process, but when you spawn that process, pool will make sure it's spawned on the node with the least load in the cluster. So obviously you can see why that would be useful to distribute the load of some kind of distributed process, set of processes over the cluster. Unfortunately, it requires you to use that kind of code server thing to set up all your nodes, and that's not really an option for us, so it wasn't able to use that. And there's a few other libraries in there that are kind of do sort of similar things like that are sort of not the way that we do things anymore. So setting up those nodes using an existing node, it will actually use a remote shell like RSH, which is totally obsolete at this point, completely replaced with SSH to try to start that node. So it would mean that your nodes would have to have an open R shell thing accessible on them, which I don't think any modern system has that set up by default. So, yeah.
I just wanted to give a warning to everyone that the SSH library is incomplete in that you can be a client in a server, but you can't do the full protocol, because I tried to do -L and -R tunneling, and it doesn't work. It's just not implemented. If you look at the history, the SSH library was kind of accepted as someone wanted it in OTP, and it was when OTP didn't require as good of testing, and so you can't tunnel with it.
Okay, yeah. So yeah, don't use it if you need to tunnel, but still might be kind of cool.
Anyone
It
else?
also, I just want to mention, SSH, the library also has some interesting support for, so I think the SSH protocol itself has some stuff built where you can create extra services that run in separate channels within a single SSH connection. And you can actually create your own custom kind of channel handlers or whatever they're called.
Hey, do you have an example of a dependency that you had and you replaced it by something built-in?
Yeah, sure. I think I maybe mentioned this, but with disk log, we had a system in MBA in play where we would record games and play them back into the system. And we were putting that all into one file, which we would load fully into the system when the system started. And so we use Vagrant for development. and the VMs that are started by Vagrant default to a 1 gigabyte amount of RAM. And for the particularly large recordings, when we would load those into memory at the beginning of the application starting, it would cause the VM to crash because we'd run out of RAM. So by switching to disk log, we were actually able to, instead of using something that we had built on our own, we were actually able to avoid overloading, the amount of memory we were using at any given time, and have good performance on the loading as well. Sped up the startup of the application quite a bit because it didn't need to read the whole file.
Anyone else? No.
Hey, I'm just kind of getting into Elixir, so you mentioned Heart, which would restart your beam if anything locks up or goes wrong. So I guess my question is, I thought in Erlang you could just let stuff die. And you could.
So like, as wonderful and as programming gods as the OTP creators are, there are things that can go wrong in the beam. The biggest thing is running out of memory, right? Like, so as far as I understand it, and I would love to be corrected on this, but there's really no way to know in an Erlang application that your system's about to run out of memory and that maybe you should do something to deal with it. So in that case, Heart's useful because if you run out of memory, let's say because you have some sort of leak that occurs over a long period of time, having the VM be automatically restarted by a separate process which doesn't get killed by maybe the out-of-memory killer on your system or whatever, might be useful.
I think this will be the last one.
I've heard different opinions about wrapping Erlang libraries with Elixir libraries, and curious what your opinion is on that.
Don't do it, except when you should. So I myself have made this mistake. So I wrote a wrapper for a library called ErlangExec, called xexec, of course, which pretty much just took the ErlangExec API and wrapped it and made it so you could pass it binaries instead of car lists and all that kind of stuff. I don't think that it really added anything to the experience of using ErlangExec, right? So I don't think it was worth it. On the other hand, GenState machine for GenStateM provides concrete things that are nice to have in an Elixir environment on top of what's provided by the Erlang solution. So you get the automatic generation of the callbacks that you haven't defined. You get the automatic backwards compatibility between 19 and 20 OTP. And also a nice feature is that we have an error translator built into GenState machine. So any errors that come from GenStateM, normally the string will be formatted in a way that your terms, your errors and such will look like Erlang terms rather than Elixir terms. But we'll actually get that error translated into an Elixir error, with Elixir formatted terms, and then push that out. And it looks like the errors from your Gen server or your those sorts of things. So yeah, but yeah, just avoid just like going like, oh, you know what? Like I don't want to type a colon at the beginning of my module name, so I'm going to wrap it. Like don't do that. That's about it. If anybody else has any more questions, yeah, all right, just wants to chat, feel free to come up and talk to me.
One more? No? Okay. Thank you.